I'd like to show you how we can make use of a normal distribution. A normal distribution is completely characterized by two parameters, the mean and the standard deviation. And if we're willing to assume that this data is normally distributed, which is questionable in this case, and we'll come back to this issue later on in another video, we can compute probabilities based on a normal distribution using the function normdist. We need a parameter x, which is a price here, and I'll explain in a second what the result is telling us. We need the mean. I'll fix that by pressing button F4 again, standard deviation again fixed, and we want to compute cumulative probabilities. So we get a number 3.9% for the probability of observing prices below 50,000, again assuming a normal distribution and taking mean and standard deviation from that sample. We can do that for other entries here. So for instance, we get a probability of observing prices below 200,000 using or assuming a normal distribution, and that probability is 63%. Now, if we would like to compare this, I call this cumulative normal. We would like to compare these percentages to the frequency counts that we've done before. We need to convert these numbers, these number of cases, these counts also into percentages. And I call this now cumulative empirical to make a distinction here between the assumption of a normal distribution and making no assumption, but rather using directly the information from the data. So I take this entry here and divide it by the total count, fix that, and convert these numbers also in terms of percentages. So for instance, I would now say that the probability of observing values below 200,000 is about 71.5%. So these 522 cases below 200,000 correspond to an empirical probability of about 71% compared to a normal probability of 63%.